Let's now look at the concept of double integrals. Just like the name suggests, double integrals mean integrating two times. So suppose you have a function of x, y, then you first integrate it with respect to x and integrate then with respect to y. So this is an example of double integration. So this is what we are going to see in this particular topic. But before going into the mathematical definition of double integrals, let's first try to understand it with the help of an example. So let's consider the case of a sports field. In this case, I've shown a cricket field. The example works with any field which has grass in it. For the sake of convenience, I am going to consider a rectangular sports field. The objective is to find out the amount of grass that is present in this particular field. So suppose that I know that the number of grass per unit area as a function of x and y. Let's say function of xy equal to xy square. This gives the number of grass per unit area at any given location x comma y. So at any given point x and y, I can return the number of grass per unit area at that particular location. So knowing this information, how are we going to find out the amount of grass that is present in the entire area? Well, this here is a small unit which has length dx and dy. So at this particular point, we have the amount of grass as a function of dx and dy. It will be dx into dy the whole square. Now we have to find out what is the amount of grass in this entire length. So this length which is along the x-axis at a given point in y. So this length is what we need to find out, and that we can find out by integrating dx from 0 to 2, right? Because this was a small length, and if I integrate this from 0 to 2, I am going to get the complete amount of grass that is present in this length. Okay, so that is what is the meaning of single integration. So if I integrate xy square into dx between 0 and 2, that's going to give me the number of grass per unit length in this yellow strip that I have just marked. So this yellow strip is going to give me the number of grass per unit length that is present in the field. Now if I go on integrating these unit strips, well, this unit strip has a width of dy. So if I basically integrate this in the y direction, that is from 0 to 1, I'm going to get the complete area. So after integrating from 0 to 2 xy square dx, which gave us the amount of grass in this strip, we are going to integrate that strip over the entire y. So we're going to integrate that from 0 to 1. So this will give me the total number of grass in the field. So the integration is going to be pretty simple. First we integrate the inside integral. So that is going to be with respect to x, considering y as a constant. So that's going to give me x square y square by 2, and evaluating it between 0 and 2. Remember, the 0 and 2 are for x and not y. So that's going to be 2y square dy, and that has to be integrated between 0 and 1, and when you do that you will get 2y cube by 3, and that has to be evaluated between 0 and 1. So the total number of grass that is present in this complete area is going to be 2 by 3 million, because this was in million. So you have 2 by 3 million grass. So that's what double integration helps you to find out. It helps you to find out the total number given the number present in unit area in terms of your location x and y. Now does this double integral really depend on what integration do we do first? Not really. If we would have integrated y first, so if we would have integrated between 0 and 1 with respect to y, and then integrated that strip which has a width of dx across 0 and 2, we would have still ended up getting the same answer, which is 2 by 3. So with double integrals of this kind, there is no dependence on the order. We can use any order and we will still get the same answer. So this is the concept of double integrals.